Good morning, my homies. We're starting chapter 8. Chapter 8 is all about right triangles. And right triangles have a bunch of special things about them. We're going to talk a little bit about trigonometry and just do some. I think chapter 8 will be pretty fun, but it's kind of meaty, okay? So put your thinking caps on. Get ready to go. We're going to start with section 1, and it's on what's called the geometric mean. So you guys remember what proportions are, right? Proportions are like 3 is to 6 as 6 is to 12, right? So a proportion is two fractions that are equal to each other. And in a proportion, and I'm not sure that, like, I don't remember teaching my algebra class these names. These are kind of older names. But a proportion has what's called the means and it has the extremes. Okay? So the extremes are these two numbers, here and here. And honestly, maybe I could look it up, but I don't know off the top of my head why they call them the extremes. Maybe if you think of it as a sequence, this comes first, this comes last, so they're on the ends, they're on the far ends. And this number here and this number here are what's called the extremes. The means. So means, okay? And this is an extreme. So, the geometric mean is it's when the proportion has the mean that's the same number, and the one I set up here is that way. Okay, so 6 would be the geometric mean in between 3 and 12. So it's not the average. It's not the the mean when we talk about it like average. Because the average of 3 and 12 is not going to be 6. But this is the geometric mean. So if I wrote it like this, A over X equals X over B, it's when this number is the same that's the geometric mean. Furthermore, I think you remember when we talked about proportions in algebra, that when you cross multiply these things, they always turn out to be equal if it's a true proportion. And you can see that 3 times 12 is 36, 6 times 6 is 36, they're equal. So if you look at this, AB, is that on screen? Yes. Equals X squared, correct? Cross multiply, cross multiply. If I want to find out what X is, in other words, what the geometric mean is, I have to take the square root of both sides. And so I end up with X, that's the square root of X squared, equals the square root of AB. So anytime that you want to find out the geometric mean of something, and it's set up like this, you multiply the extremes and then take the square root of them. Okay? All right, so there's your algebra foundation. Now let's launch into what this has to do with right triangles, okay? So let me erase this. All right, so the first thing they tell you is that if you have a right triangle, and you draw, here's the 90-degree part. And you draw the altitude of that right triangle. Maybe I should do it in a different color pen. I draw the altitude, which comes down at a 90-degree angle. Anytime you draw the altitude of any right triangle, it splits this triangle into two other triangles that are, first of all, they're right triangles. But the cooler thing is it splits them into similar triangles to the original. And you can quickly, I think, in your mind, kind of prove that to yourself. If I drew, let's just look at this one here, okay? So we've got the big one that look kind of like that. And we've got the smaller one that looks like that. Can you prove to yourself that those are similar? I hope you can. We can see, first of all, there's the same angle there. There's a 90-degree angle. And so either if we could prove there's another angle that's the same, or two sides that are similar, then we're golden, right? Well, you can easily prove there's another angle the same. Look, this one here, this is the same angle as this right here. Do you see how it's just like it's overlaid on top of it? So we've got angle similarity, so we know those triangles are similar. You can do the same thing for this side. This chops this into a small triangle. This angle is going to be the same. This angle is going to be the same. So anyway, and what's kind of cool is you can keep doing this. You could then chop this triangle into two triangles, and they're both going to be similar. You could take those and chop those into two triangles. They're both going to be similar. You could then chop that. I mean, you could keep going ad infinitum. Okay. So that's theorem 8.1. 8.1 says an altitude drawn to the hypotenuse of a right triangle splits the triangle into two similar triangles that are similar to each other and similar to the original one. Now, let's get to the geometric mean and how this works all out. So, theorem 8.2. And I guess I'll just leave this up here. I got to get some letters in here for you. So we got A, B, C, and let's call this, see how this ends up chopping the hypotenuse into two smaller segments? We'll call this X, that's from here. And Y, we'll call that here to here. Okay, does that make sense? All right. So, 8.2 says that the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments, and we're calling them X and Y. The length of this altitude is the geometric mean between the lengths of these two segments. Do you think that's kind of cool? Okay, so this let's just call this H for the height of the altitude. So what they're saying is, which one's smaller here? I guess Y is smaller. So Y over H is the same thing as H over X. This is the geometric mean between these two segments. Doesn't matter what shape your crazy right triangle is, it does it every time. Think about like some Greek dude with just a stick, and he's drawing in the dirt and he's figuring this out, and that is true. That's kind of amazing. You never figured that out when you were little with your crayons. All right. So if you want to find out what H is, remember our little formula? H is going to be the same thing as X times Y, the square root of X times Y. So if you knew these two numbers, multiply them together to take the square root, and that's always going to be the height. All right, let's try to do 8.3, and that'll be the last thing. I think I'll leave these same numbers, except I might need to add a couple more. Do I? Yeah, I think it would probably be a little easier. let's call this G, so that's this length, and F. I'm kind of going in reverse alphabetical order, I guess, but that's okay. So this is 8.3. So it says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So what this one is saying is we've drawn an altitude. It splits this hypotenuse into two segments. The length of either leg here, like let's just take G, let's concentrate on G, okay? So it says that, you know what? I'm going to call this whole distance, just for ease, I'm going to call this Z. I could say X plus Y, but it just makes it a little messier. So the length of this leg, G, so Z over G is G over, now we want the leg, sorry, let me just look here. Oh, that's what it is. Okay, so it's the whole hypotenuse over the leg, and the leg over that part of the hypotenuse near there. So it's over X. You could do the same thing on the other side, and it would be Z over F is F over that small part of the hypotenuse here over Y. Okay, that is theorem 8.3, and that's the last of it. I understand this is meaty, okay, so you're going to have to do some practice to get this cemented in your heads. But it's pretty useful, and it's kind of, I think it's kind of fascinating that you know, ancient peoples could figure this out just by kind of almost like by trial and error. Okay, that's all, and we're going to keep working through this chapter. It's going to be good, okay? All right, talk to you later.